Welcome to your Finite Math R3 Day 1 or Part 1 lesson. Today we're going to look at rational expressions, and we're just going to look at multiplication and division. So our objective today is to simplify rational expressions specifically involving multiplication and division. For all mathematical expressions P, Q, R, and S, with Q and S not equal to 0. Okay, so P over Q, so when we're talking rational expressions, we're talking about fractions involving algebraic expressions. That's what we're talking about. Now, the very fundamental property is that P over Q equals P times S over Q times S. In other words, you don't change the value of a rational expression if you multiply the bottom by something and the top by the same thing. The multiplication property is just like multiplication of fractions. P over Q times R over S is equal to P times R over Q times S. P over Q divided by R over S is just like multiplication of fractions with numbers. You just multiply by the reciprocal of the second fraction. So P over Q divided by R over S is equal to P over Q times S over R. Just a reminder, when you're dividing powers with the same base, we subtract exponents. You look for a particular base and see where the larger power lies, whether it's in the numerator or the denominator, and that's where you're going to end up. So if we just quickly simplify x to the 5th times y squared divided by x squared times y to the 6th, for the x's, we look and we go, okay, the larger powers in the numerator. So 5 minus 2 is 3, so we're going to end up with x cubed in the numerator. For the y's, the larger powers in the denominator, so we're going to have a y in the denominator, and it's going to be to the power of 6 minus 2, so y to the 4th. Now, if you'll notice in this particular problem, there were no pluses and minuses. We had x to the 5th times y squared over x squared divided by, times y to the 6th. There's no plus or minus. When there's pluses and minuses, you have to physically factor and then see if you can reduce. Okay, you have to factor and then reduce. Up here, we were working with factors everywhere because there's no plus or minus. Here, we have to actually pull out the factors. So for part A, we've got 36y squared plus 72y over 9y. Because there's a plus in the numerator, we have to physically factor the numerator. So looking at those two, we can bring 72 is 36 times 2, so we can bring out a 36. We can also bring out a y. So we've got 36y times, 36y squared divided by 36y gives us y, plus, and then 72y divided by 36y just gives us 2. So we rewrite the numerator as 36y times y plus 2 divided by 9y. Okay. So now we look at the 36y and the 9y and see what we can cancel. But first we have to think about the factors. 36y is equal to 4 times 9y. And then we have our times y plus 2, and then we have our 9y on the bottom. So then the factor 9 matches with the 9 on the bottom. The y factors with the y, matches with the y on the bottom, and so we can cancel both of those, and we're left with 4 times y plus 2. Now, if you wanted to write this one, since it's just 4 times y plus 2, if you wanted to write it as 4y plus 8, that's great, or you can just leave it as 4 times y plus 2. All right, for the next one we had k squared plus 7k plus 12 divided by k squared plus 2k minus 3. Because there are pluses and minuses in the numerator and in the denominator, we have to factor both completely. Okay, so these are trinomials, so you'd use the AC or trial and error method. So k squared plus 7k plus 12 is equal to k plus 3 times k plus 4. K squared plus 2k minus 3 factors out to be k plus 3 times k minus 1. If you're still struggling with factoring, you need to come in and see me, and we need to work on that, because you need to be able to, when I say, okay, we factored this, and then I show you the factor form, you need to understand what took place in the middle. So again, if you're struggling, come see me. All right, so then once you've got the numerator factored and the denominator factored, you look for where factors match up. The k plus 3's match up. You've got one on top and one on bottom. As long as that's the case, and remember, this is all or nothing. when you're canceling binomials, anything with pluses and minuses, they have to match up exactly. That k and that 3 are married to each other, and the only way they can be canceled out is if they're both canceled out. So we can cancel the k plus 3 with the k plus 3, and we're left with k plus 4 over k minus 1. Now, you can remove the parentheses at this point, but sometimes I've found that if students leave them in, it reminds them that they are married together because of the plus and the minus. And since k plus 4 does not match up with k minus 1 exactly, we cannot factor. Or cancel, rather. All right, so we're going to perform each operation. For part A, we're multiplying. We've got 3y plus 9 over 6 times 18 over 5y plus 15. What we want to do is we want to go ahead and factor just in case there's anything we can cancel. So we can factor 3 out of the 3y plus 9. So we've got 3 times y plus 3. And go ahead, 18 is equal to 6 times 3. We can think of it like that. And then we've got a 6 on the bottom. And then for the 5y plus 15, we can factor out the 5. Let's see what matches up. Let's see, the y plus 3's match up. The 6 on the upper right and the 6 on the lower left match up, and so we can cancel everything that matches up. And so we've got 3 times 3 over 5. Now, somebody may be saying, well, that 3 and that 3 match up. Yeah, but they're both on top. Remember, you have to have a factor that matches on top and matches on bottom to be able to cancel. And so we've got 9 over 5. So why do we have to have one on top and have one on bottom? Well, because relative to the whole problem, for instance, we're multiplying by 6 and we're dividing by 6. So what we're really doing is we're finding pairs that reduce down to 1. The 6 over 6 reduces down to a 1. The y plus 3 over the y plus 3 reduces down to 1. 3 times 3 gives us the 9 in the numerator. It doesn't reduce down to 1. Okay? For part B, we've got m squared plus 5m plus 6. Yep, because there's pluses there, we're going to have to physically factor that out, and we're going to do that in just a second. And over m plus 3, we'll have to see if that can factor, or if it's prime. And then we've got times m, and then m squared plus 3m plus 2 we'll have to factor. Well, m squared plus 5m plus 6 factors out to be m plus 3 times m plus 2. M plus 3 in the denominator there, that's just a little binomial and it's prime. So we'll just put parentheses around it just to remind us that the m and the 3 are married to each other and that they have to cancel together if they're going to go anywhere. And then the m on top is just m. And then m squared plus 3m plus 2 factors to be m plus 2 times m plus 1. So now we've got the whole numerator factored, we've got the whole denominator factored. We need to look for matching pairs on top and bottom, because remember, if they match on top and bottom, they form a factor of 1 together. So let's see, the m plus 3 on top and the m plus 3 on bottom make a pair that equal 1. The m plus 2 on top and the m plus 2 on bottom make a pair that equal 1. And then m over m plus 1, those don't match exactly, so we can't cancel them. And so our final answer is m over m plus 1. All right, let's do a division problem. We've got 2m squared minus 5m minus 12 over m squared minus 10m plus 24, and we're going to divide that by 4m squared minus 9 over m squared minus 9m plus 18. So the very first thing we want to do is take that second fraction, we want to flip it and change it to a multiplication problem. Then we want to factor, because right now we can't cancel anything because we haven't factored yet. And we've got all kinds of pluses and minuses. So let's see, 2m squared minus 5m minus 12 factors to be 2m plus 3 times m minus 4. Let's just double check. Let's see, the 2m times m would give me 2m squared. 2m times negative 4 gives me negative 8m, plus this 3m gives me negative 5m. 3 times negative 4 gives me negative 12. So we're good to go there. M squared minus 10m plus 24, that's going to be m minus 6 times m minus 4. And again, you can FOIL that out to double check that it works. In the upper right hand corner, we're going to factor our trinomial to be m minus 3 times m minus 6. And then down here, the 4m squared minus 9, that's a difference of 2 squared. We got dots here. And so that factors to be 2m minus 3 times 2m plus 3. So we want to look for top and bottom matches that equal 1. So 2m plus 3 in the upper left hand corner matches with the 2m plus 3 in the lower right hand corner, so that forms a 1. The m minus 4's match up, so they form a 1. And the m minus 6 and the m minus 6 match up, and so they form a 1. And so we're left with m minus 3 over 2m minus 3. Now, some people may want to, cancel there. You can't, because they don't match exactly. They're part of a binomial. They have to match exactly to be able to reduce. Okay, guys, it is extremely important that you can do the problems to try on your own. If you cannot do them, please either review the video or come in and see me or go to get some peer tutoring. Whatever you need to do, you need to be able to do those problems to try on your own before you come to class. It is critical. All right. Either come see me before class, or I will see you in class, and I hope you have a great day.